chaps, this is our third lesson of the week, and we're still working with calculating probability of compound events, but now we're going to look at events that have uneven chance. Until now, when we tossed a coin, we either got a head or tail. It was half-half, chances were equal. When we're throwing a dice, there was 1 divided by 6 probability for getting a 1 or a 2 or a 3 or 4. Each one of them was even. So then we're going to look at events that are not even. So I'm in the example on page 317 and the exercise in page 318. So I'm again throwing a dice, but I'm going to draw a tree diagram, not for each number that I got, but only for 2 possibilities. One, we'll call it event A. So event A is if I got 4 when I threw the dice. So that's event A. And then the other event that I've got is event not A. What does it mean, not A? In other words, not getting a 4. In other words, it's getting 1, 2, 3, 5, or 6. So not getting 4. And the first thing, eventually we're doing it twice. So we're throwing the dice, we either got A or we didn't get A. Then we're throwing it again, and again we either got an A or not A, And we're going to answer a bunch of questions about that compound event. And first of all, they ask us to complete this tree diagram by eventually writing down the probability of each branch and the total probability of getting these compound events. Okay? So let's start by writing the probability. Okay? So the probability of getting an A, we say is a half, and the probability of getting a not A is a half. Okay? And then again here is a half, and this is a half, just like we've done before, right? All the same. But, sorry, hello. Icona. What? Vuyokazi, how are you doing? Oh, sorry, so this is teacher Vuyokazi. Nice to meet you guys. So what's the problem? Okay? What do you mean? No. This is half. What's wrong with that? Shut up, Andy. Shut up. Okay, I'm sitting down. Okay. Tula. Okay, what's the problem? You tell me. Okay, children, listen to me. What is wrong with this thing here, Mr. Elisham? It's complete nonsense, okay? That's not half. The probabilities, these events are not even. They're not equal to each other. Give me the pen. Here's the pen. No, you're going to have to do it. Okay, I will do it. You just tell me what to write. Okay. Sorry about guys, I'm a little bit in trouble here. Okay. So, what teacher Vuyokazi is saying is that the probability here is not half. The probability of event A, for us to get the number 4, is just 1 out of 6. You're right? Yes, thank you very much. It's just 1 out of 6. This is just 1 4 out of the whole numbers. Now I get it, sorry. And therefore the probability of not getting A is 5 over 6. Yes, okay. It's 5 over 6. Okay? You see, we're talking about events here that are not even. So the probability of getting a 4 is not equal to the probability of not getting a 4. Probability of getting 4 is 1 over 6. And just like Professor Popik told us last time, the probability of getting not a 4 is 1 minus a 6. Remember that? Okay, a probability of getting 1, 2, 3, 5, or 6. We add them up, it's 5 over 6. And of course, we need to fix up these ones, right? The same thing? Yes, okay. So it's, what is that? That will be 1 over 6. Probability of not getting an A is 5 over 6. Probability of getting an A here is 1 over 6. And the probability of getting here is 5 over 6. I think I can carry it. Do you mind if I do? Okay, bye-bye. Teacher Lakazi, Vuyokazi. I'll see you later. Okay, so now we need to write down what are the compound events. So in this branch, I got, let's do it in another color. And here I got 4 and then a 4 again. So in other words, I got A and another A. Here I got an A, I got a 4 and then a not 4. So it's A and not A. Okay, do you understand what I'm doing here? It's just compounding the events. Here I got a not A and then an A. So not A and then an A. I'll put a comma between them. Here I got not A and not A. So twice I got not A. Not A, not A. Okay? Not A means I didn't get 4. Okay? Now we need to calculate the total probability for each one of these 4 events. We can't just say 1 out of 4, okay, because teacher Lakazi, Vuyokazi will be very, very upset with us. You'll be very upset, okay? Because they're not equal. The events are not equal. They don't have the same likelihood. So how do we do that? We use what Professor Pupik taught us, okay? What's the probability of getting A and then an A? It's going to be 1 over 6 times 1 over 6, which is 1 over 36. Remember, he told us to multiply the branches for this to happen, and then again to this happen. And we need to multiply, okay? 1 over 36. What's the probability of having an A and then a not an A? I'll write it more like this. It will be the probability of getting an A times the probability of getting not an A, okay? It's the same thing. I just didn't write it down here. So it's going to be a 6 times 5 over 6, which is 5 over 36. Okay? What's the probability of getting a not A and then an A? Well, it's going to be the probability of getting not A times the probability of getting an A. Sorry, not an A. Sorry, yeah, A. Okay, so it's going to be 5 over 6 times 1 over 6, which again is 5 over 6 for 36. What's the probability of getting not A twice, one after another? Well, Professor Pupik says the probability of getting not an A times the probability of getting not an A second time. So that's going to be 5 over 6 times 5 over 6, 25 out of 36. Okay, and this is the first thing I ask us to do. Calculate the probability of each one of these possible events. We use the 3 rules of Professor Pupik, multiplying the branches, okay, and remembering what teacher Lakazi Vukazi said, that we can't just assign half because these are unequal events. Now I'll pause you here and we're going to start answering some questions. Okay, so it's very important when you solve these problems, first of all, to complete the tree diagram, including the probability of each branch and the probability of each one of these compound events. These ones that are wrote in green are the compound events. They're made out of 2 events. Okay? Only then try and answer the question. So they're asking us, what's the probability of getting 4 in the first row? Well, in fact, we didn't even need this whole second part. What's the probability of getting a 4? That means the probability of an A is just 6. 1 over 6. It's the probability of getting a 4. Okay? Okay? Next one, what's the probability of not getting a 4? So I can either just look at this, alright, not A is 5 over 6, or like Professor Pupik said, probability of something not to happen, or for something to happen is 1 minus the probability it doesn't happen. So I can do 1 minus 1 over 6. Either way, I get 5 over 6. Okay? Now we're becoming a bit more interesting. What's the probability that the first toss, I'll just stand here, the first toss I got a 4, and the second toss I didn't get a 4. So I can have a look here, okay? Where do I have an A in the first and a not A in the second? Which branch is that? So an A and not an A. And already, because I did all the hard work, I calculated the probability of that branch. Remember, that number is the probability for this branch, for A to happen, then not A to happen. And the answer was 5 over 36. So you see, if you do all the hard work here, it will make it very easy for you to eventually actually answer the question. Pause you here, we'll move to the next few questions. Okay, so the next question they're asking us, what's the probability of not getting 4 twice? In other words, I didn't get a 4. I tossed the coin twice, and I didn't get a 4. So we look at the branch. That's basically not A, not A. The probability was 5. Okay, not A for the first time. Again, not A. The probability is 25 over 36. Easy. The last one is a little bit more difficult. Okay, we'll just move here for a second. I want to calculate the probability of getting 4 at least once when I tossed or threw the dice twice. Okay, so at least I get 1 4. Okay, so there's a couple of ways of doing it. Let's just look at all the branches that fits, qualified. So I want to get 4 at least once. So either it's this branch, I got 4 twice, or I got 4 and then I didn't get a 4. That qualifies. So that's fine. I'll write that. That's fine. That's fine. Or I didn't get a 4 and then I got a 4. So that's fine as well. So the only one that doesn't fit is not getting 4 twice. Now, what I can do, like Professor Pupik said, what I can do is add all these probabilities that qualify. So I'll write it down. I'll just write it down. So it will be 1 over 36 plus the probability that was probability getting 4 twice. The probability of getting 4 in the first time, but not in the second time, is going to be 5 out of 36. Plus the probability of getting, first of all, not 4 and then getting a 4, which again is 5 out of 36. I'm getting 11 out of 36. Okay? That's the probability of getting 4 at least once. But let's use the third rule from Professor Pupik. Okay? What's the probability of getting 4 at least once? Well, according to Professor Pupik, it's going to be 1 minus the probability of not getting 4 at all. Okay? Because the probability of getting 4 at least once, for that not to happen, that means I didn't get 4 at all. So according to Professor Pupik, what I can do is 1 minus the one event that doesn't qualify. Okay? So that's going to be 1 the probability of having not A, and again not A. 2 times I didn't get 4. And that's going to be 1 minus the probability that says here. I'm just copying it from here. 25 over 36. And if you do that, you will find out the same result happening. 11 out of 36. Okay, guys? Right now you can work on exercise 2. Okay? Exercise 3. Okay? You should know everything you need to know. I'll see you in the last lesson later. Cheerio.